Assalamu alaikum. We are starting with this question, June 2020, paper 22-6. This is basically DC circuits. There are two main topics in DC circuit. There are two main topics in DC circuit. One is Kirchhoff rules and second is potentiometer. A battery of EMF 7.8 volt and internal resistance R is connected to a filament lamp. The total charge of 750 coulomb moves through the battery in a time interval. The total charge of 750 coulomb moves through the battery in a time interval of 1500 seconds. During this time, the filament lamp dissipates 5.7 kilojoule of energy. The EMF of the battery remains constant. So they have given you the charge, they have given you the time, and they have given you the amount of energy dissipated. Explain in terms of energy and without a calculation why the PD across the lamp must be less than the EMF of the battery. What is the concept there? Actually, EMF is the total voltage produced by a battery. Some of the voltage is lost within the battery and the remaining is available for the external circuit. This is the issue of internal resistance. Internal resistance always utilize some of the energy in the circuit. Always utilize some of the electrical energy in the circuit. Now, read the question again. He says, why the PD across the lamp must be less than the EMF of the battery. So you will tell the examiner that, look, some PD appears across the internal resistance R. This is June 2020, paper 2-2, question number 6. DC circuits is the topic. Some of the voltage is lost across the internal resistance. So it's a battery of EMF 7.8 volt. Now calculate the current in the circuit. If you have a topical past paper book, it would be ideal that you open the book in your own, so you can look back the question always.
0.5.
0.5. How come?
Sin 50 upon 1500.
Acha, good. The current in the circuit. 750 is the coulomb and 1500 is the time. So I is equal to Q upon T. We are presently doing June 2020 paper 2 question number 6. V is equal to W upon Q. Voltage is equal to 5.7 into 1000. And the amount of charge is 7.750. So when you solve it, you will get this answer. 1000. 1000 is kilojoule to joule m. 1000 I'm using because I have to convert kilojoule to joule. 20 upon 20 plus 30, V output is R1 upon R1 plus R2 into V input. There are two resistors. If you have any audio problem, sometime it happens, so please let me know if there is any audio problem. A potential divider circuit is produced by connecting the three resistors to a battery of EMF 9 volt and negligible internal resistance. The potential divider circuit provides an output PD of 3.6. Circuit diagram is shown. So you can see 9 volt is the total. My two resistors 9045 is giving me, the combination is giving me 30 ohm. So now I place them here. Now this is the formula. This is the formula of a potential divider. V output is equal to R1 upon R1 plus R2 into V input. So I can put the values here and I'm getting a 3.6 volt. So I should take my output across 20 ohm. V out is equal to 3.6 volt. June 20, paper 2-3. June 20, paper 23-5. Define volt. So how we define volt? Anyone can answer how we define volt?
When 1 joule of energy is used,
Okay, so as Ahmed said, we can use it as a joule feature. We can say that actually volt is joule per coulomb. So actually the formula is voltage is equal to work upon charge. It means joule is equal to volt is equal to joule per coulomb. Right. So 1 joule of energy drives a charge around a circuit, right? So volt is equal to joule per coulomb. The figure shows a network of 3 resistors. Calculate the combined resistance of the 2 resistors connected in parallel. In parallel, we use the formula R is equal to R1, R2 upon R1 plus R2. So solve this and let me know the answer. Please solve this equation.
75.
75. Very good. Achha. The total resistance between terminals X and Y. The first two are in parallel and the third 55 is in series. So I will use the formula for series. The network in B is connected to a power supply, so there is a potential difference between terminals X and Y. The power dissipated in the resistor of resistance 55 is 0.20 watt. Calculate the current in the resistor of resistance 55. The power across 55 is 0.20 watt. 0.20 watt. We have the power, we have the voltage. So we can find the current. Power and voltage is known. So we can use P is equal to V square upon R. This is one option. Or we can use, we have power and volt. We have power and we have resistance. So we can also use power is equal to I square R. Power is 0.20. You have to copy this and solve this. Let me know the answer.
0.06.
0.06. Okay. Then he says, what is the current across 300 ohm resistor? The effective resistance is 75. So first we solve for 75 and then we can find it. We know actually the current is the same, but the ratio is 300 is to 100. The ratio, we should see the ratio. 300 is to 100. In parallel, current is divided. It is 3 is to 1. It is 3 into 1. So I will use ratio upon sum of ratio into total. So I will use 3 upon 4. And my total current was, which is coming in line, is 0.06. Ratio method is very effective. And whenever you are using a ratio method, you can directly solve it. Achha, current is divided in the reverse ratio. Let me make a correction here. Current is divided in parallel. Current is divided in the reverse ratio of resistance. In parallel, current is divided in the reverse ratio. To solve this,
Sir, 0.015.
0.015. Good. Calculate the potential difference between X and Y. Now look at this position, X and Y. It is the total circuit. The total resistance of the circuit is 130 and the current we have, the total current is 0.06. So we can use the total resistance and the current to find. We have the total resistance across XY. The total resistance across XY is 130 ohm. Current is 0.06 ampere. And we need to find the voltage. Look at this. Now copy this working and solve it.
7.8.
7.8 volt. So we are stopping here and we will inshallah continue in our next class. Thank you. Allah Hafiz.